On the bench today we have a X-Force, I guess this is a 200 power supply, so I'd have to assume 200 amp power supply. Customer sent this in. He had apparently sold this, and it was working, and I take him at his word. I've done a lot of radios for this guy. He's likes his equipment right. When I restore him, he wants, he wants it done to the max, and he's not a mod person. He likes them back factory, the way stuff's supposed to be. The manufacturer designed it. But I guess he didn't need this anymore. It was working fine. He sold it. I'm not sure where he sold it at. eBay, Craigslist, or something. Maybe, but it got shipped to whoever it was. They apparently got it, and it didn't work, I guess. They took the covers off, or they took the cover off of it, and he doesn't know what's been done to this thing. So, he had it sent to me to take a look at it. See, he said, it's an X-Force power supply. Can you fix it? He said it's got, I think he said it's got Meanwell power supplies. I'm pretty sure I remember him saying Meanwell, which would be a good thing, because Meanwell makes good supplies, but we'll see. But it definitely uses switch mode power supplies, because at 200 amps, if this was a linear supply, I wouldn't be able to do this. Two fingers, if it doesn't slide back far enough, but put two fingers under it and pick it up with two fingers. I'm not the Incredible Hawk, and if this was a 200 amp power supply and was a linear power supply, I'd never be able to do that, because it would have some huge transformers in there. So I'm not going to plug this in yet. I want to get the top cover off of it first. And anytime you work on something like this, and it's not just power supplies, radios, televisions, anything like that. If it's not yours and it didn't break on you, so it was working 1 minute, it stopped working, maybe no magic smoke came out, it just stopped working. Might be one thing, but when you have equipment sent to you, never plug it in before you take the covers off. You never know what might have happened just in shipping. It may have been safe to plug in before it arrived at your door, but in transit, getting bounced around, something could have come loose. So you don't want to plug something like this in, touch it, and you light up like a light bulb. So always take the covers off. Just do a quick visual inspection to make sure that nothing broke loose, the AC wiring looks safe, you don't see a bunch of charred, smoky looking stuff in there. But it looks like a fairly simple layout. It's got an on-off switch. Assume it has to be the voltmeter most likely. And I guess this would be a variable control. Now the one thing I'll be interested to see is, because I've never had a power supply actually from any amplifier manufacturer, so I have no idea what to expect when I open this up. But I would assume they're using, or they at least should be using, power supplies that are designed to be used together. You don't want to take a power supply that is designed to be used by itself and connect it either in parallel or in series with other supplies unless it's designed to be used like that. So much like the laboratory power supplies, like that HP power supply, I can hook up multiple units either in series or in parallel, but it has a sense line or a sharing line. Same thing with Astron power supplies. Now that's big one over there is actually has a blue terminal on the back of it. That terminal is designed if you're going to run two of those 50 amp power supplies in parallel. There's a wire that runs between the blue terminal on both supplies. That way it can share the load. That way when you turn on the power supply or you apply a load to the system, one power supply is not supplying all of the power, running full bore, and the other one's over there not doing anything. It evenly shares the load. So, and you can get switch mode power supplies that do that. So I would assume that's what they have in here. Judging by the size, 200 amps, I'm going to guess it probably has, I guess 4. That would be probably the best thing to do, get 450 amp supplies. I think they make 100 amp 12 volt supplies, but they're not very common. Where the 50 amp ones, because I've actually got one of those floating around here somewhere, they're not that uncommon. Now, it may even have, I don't know, like I said, I haven't taken the cover off, it may even have server supplies in it, which actually that would be a good thing. If it's got computer server power supplies in it, those things are built like Sherman tanks, because those things are meant to be turned on, and the only time they get turned off is when they're replaced. They replace those on a normal time schedule. But, you know, those things stay turned on for years running, and they're running under load for years on end. And those, again, will very frequently, I've got a bunch of old server power supplies where you can interconnect a bunch of those. They have a line that's shared between the power supply to share the load. So if we see something like that in here, thumbs up, that's good design practice. If they're just paralleling a bunch of power supplies that are designed to be used individually together, well, that's not such a good thing, because that's an easy way to nuke one supply, you know, because it's running full bore while the other one's not. So let me get the cover off of this, and we'll see what we got in here. It's got a fan in the back. That's pretty much a fuse holder, which I did notice is a little bit loose. I can pull it out about that far, so yeah, there's definitely a problem with the fuse holder. It's got the power cord, and there's a hole in the top here, which that seems a little... I guess this is maybe an amplifier box. It's X-Force, so I'm assuming this might be like a box they use to build amplifiers in. We'll have to see how it looks, the layout on the inside, but it only has one fan. There's a fan in the back, well, right about here in the back, and if you look in the top, you can see it looks like there's a piece of circuit board material, or I can see a power supply module down in through the holes there, and there's a strip of, man, that's really, matter of fact, that screw right there is touching the top cover, it looks like almost. So, how is air getting, so that's the only holes in this box. This hole here, and where the fan's at in the back. So, depending how they have the supplies set up in here, are they getting good airflow? Because the supplies have perforated their, usually if they're mean well power supplies, the mean wells are closed off on two sides, and then they have a perforated cover that goes on the other two sides. And depending how you position those, they might not be getting any airflow. So, and you could turn this cover around, because the holes are the same going around it, so you could put this over here, but yeah, I'd almost think you'd want, at least for a power supply, you wouldn't want the fan there and a hole here. You'd want, you know, a fan either on the side and a hole over here, or a fan in the back and holes in the front. That way it's drawing air or pushing air across everything that's inside the cabinet. You're not just going a short distance from fan to a hole, or from fan to the hole over here, like I say, if you flip this cover around. So, and yeah, I can see a power supply here, so that means the air is only getting directed to what's right here. So we'll see. But let me get the cover off of this and see what this needs. Like I say, apparently it worked, got shipped to somebody, didn't work. That guy took the cover off of it, and he doesn't know what that guy might have done inside, so we'll see. Hopefully just a wire got, I'm assuming it probably something simple, like maybe a wire got knocked loose. The cabinet's not bent anywhere, so it doesn't look like it took any hits in shipping. So fingers crossed, easy repair. Hoping for a loose wire or something. Okay, so this is actually the second time me shooting footage on this thing. The first time, I quite literally got overwhelmed with what's inside this box. I was thinking it would probably be an easy fix. Well, I'm not going to work on it. It may work just fine. I think the only problem is the voltmeter. Some crap broke off the back of it. But this is not safe to plug in to power. It is just, this is a fire hazard and electrocution hazard like I have never seen. It's just, wow. This is the pinnacle of examples for how not to design anything that plugs into a wall. And it boggles the mind. So I had to shoot it a second time, because I just literally needed to go through this thing to try. It's literally the only thing that's good here it's got a fancy aluminum cabinet, and it has a strain relief on the power cord. That's the only thing going for this. That's it. Everything else just has to go. It's death in a box. They might as well have put a flame sticker on this and called this the Fireball 200, because that's what's going to happen to it. It's going to turn into a fireball and hopefully not electrocute somebody. So let's just dig into it. There's nothing to it but to do it. So yeah, I'm not going to work on this, even though I think the only thing that's wrong is this flapping in the breeze. I can't do a repair on this, because if I work on this and this thing does kill somebody down the line, which it could, I'm not going to be held liable because I was the last guy that worked on this. I'm going to put a sticker on this thing that says unsafe to plug in, hazardous, unsafe to use. It's just, yeah, this should, wow. I mean, this is the kind of product, if you, this is, you know what this would be good for? Shipping to a terrorist. This would be great to send to a terrorist if you want to kill him, because it's a death trap. So let's just dig into it. Like I say, I went through it one time, and I'm sure I'm going to forget to mention some stuff, because there's just so much wrong with this thing. It's not funny, and it isn't. It's scary. It is really scary to think someone sells these. If someone made this themselves and they killed themselves and their family, that's one thing. To make a product like this and commercially sell it to people is, it boggles the mind. I just dumbfounded. I'm rarely completely lost for words, but yeah, with this thing, I'm just completely lost for words. So what I think is probably wrong with it, and I'm not going to plug it in. I'm not plugging this thing into AC. No ifs, ands, no ways, no buts. You couldn't pay me enough money. Couldn't pay me enough to work on it, much less even plug it into a wall. I think what's probably wrong with it is that this capacitor, or actually two capacitors, there's an electrolytic capacitor and a ceramic capacitor, used to be hot glued to the back of the meter movement right there, okay? And the hot's not just, yeah, they tried to glue this plastic heat shrink tubing over this cap to it, and it just popped off. When the customer sold this and shipped it to whoever bought it, that just broke off. So the meter wasn't working. I guess they assumed it probably doesn't work. So that's probably the fault. It probably works, but I ain't plugging it in to find out. So what's wrong with it? Well, everything you're looking at is wrong at it. Quite literally everything. There's nothing that's right in this thing. Nothing. Big goose egg. Let's start with the most important thing, and it's the reason I turned it in this orientation. We want to start with AC mains. That's what can kill you. The DC, it's low voltage, maybe at high current, but it's at low voltage. You can go out to your car or your pickup truck and lick both of your fingers and touch the battery terminals on your car or on your truck, and at 12, 13, 14 volts, you get a tingle, but that's about it. 120 volts AC, it can be lethal at the right conditions. It can give you from one heck of a shock to you're not going to be moving anymore ever again. Dead. So that's where we're going to start, is the safety aspect with voltage. So to start with, we have what appears to be a nice heavy power cord, which it is, and we'll get into these power supplies and why this power cord ain't going to work with these power supplies. It is grossly underrated for what this thing is going to be demanding from this power cord. So luckily, we don't have to question how much current this power cord can handle. It's got the manufacturer's sticker on it. It's made in China. That's not a bad thing. There's good things and bad things made in China. Now, this amplifier is actually a good example of everything that's wrong with cheap Chinese crap, because everything that's in here is cheap Chinese crap. But there are good Chinese, and we'll get into that later when we get to the power supplies, because these are clones. These are fake knockoffs. But this power cord has a rating on it, 15 amps. And we'll come back to that later. But what protects this amplifier and everything? If something goes wrong inside of this box of death, what protects this power cord and the circuitry from bursting into flames. The power cord, or the fuse. So and you can see, yes, the fuse holder's about, which we'll get to that. There's a lot of things wrong there too. But let's just take a look at the fuse, which just fell on the table and rolled under the amplifier. Let's find it on here. It is a 30 amp fuse. What did I just say this cord was? 15 amps. This cord will long have burst into flames and be burning your house down before this fuse blows. The fuse is rated for 2 times as much as the cord that's supplying power to it. Big no-no. Next, before we even get to the wiring, what's up with that? It's loose. Why is it loose? Why can I turn the fuse holder? I shouldn't be able to turn the fuse holder. Even if the nut was loose, I shouldn't be able to do that. Fuse holders have a flat on one side. You see that flat? They drilled a round hole in this chassis to install this fuse holder. They didn't use a chassis punch. Greenlee makes them. There's actually a lot of companies that make them. You can go to Mauser and anybody that sells Greenlee panel punches. You can buy those. Okay, 1/2 inch D chassis punch. That's what they're called. It's got a flat on one side. That flat, when it goes through a hole that has that flat, prevents this from turning. So anytime you unscrew or screw on the fuse holder, you're not rotating the body, which can loosen the nut. And what happens when you loosen the nut? This happens. Well, if that continues, what is that nut eventually going to come in contact with? The power cord. Bzzzt, right against the chassis. You've now energized the chassis with 120 volts. Now, a lot of you may be thinking, yeah, but it's grounded. There's a green wire right there. And yes, there is. There is a green wire, and actually I'll give them this is probably the only thing in this entire thing. It's done wrong, but I'll give them a mulligan on that. It'd probably be okay in the real world. You know, there's safety standards, and then there's, you know, reality. It's not done right. For starters, there is no star washer. You've got actually there's 4 metals here. You've got a copper terminal, tin plated, but you have aluminum, tin-plated copper terminal, and a steel screw. You've got dissimilar metals for starters. Aluminum loves to oxidize. So even if you clean the aluminum surface before you put that terminal on there, if you don't put a star washer, that aluminum, air and moisture can get in there, cause the aluminum to oxidize, and you can end up with a bad connection. If with a star washers make what is known as a gas-tight seal, because they actually embed themselves down into the other surface, the terminal and whatever they're being screwed down to. And by pushing themselves in, they form a gas-tight seal. It's the same principle behind what are known as IDC connectors, or insulation displacement connectors. They work on the same principle, a gas-tight seal. But yeah, it's not right, and it's soldered. These aren't supposed to be soldered. It's supposed to be just mechanically crimped, and that's it. But yeah, that'd probably be okay. But if you ever had a problem here, and that touched the chassis, this would be at 120 volts live. What if you had a problem with the power cord, or maybe the problem with ground at your outlet, or a problem with your breaker panel, or even at your ground rod? The ground can fail, so you always want to make sure you do this stuff properly. That way, if the ground fails, you've got a second layer of protection. That's why they have that flat, so the nut can't come loose. Also, there's no Loctite on the nut. There should be Loctite. And if you ever take open just CB radios, look at base station CB radios, look at the fuse holders. Doesn't matter who made them, they always have Loctite on the nut. That way, even if it could turn, it still's not going to unscrew because it's got Loctite on the nut. Yeah, that's bad. The wiring in this thing, holy smokes, because that's what it's designed to do, make smoke. Look at that terminal right there is a perfect example. That terminal has a hole in it. How did they attach the wire to that terminal? They laid it on the terminal and just put a blob of solder there. they didn't put the wire through the hole and then bend it over. Same thing here, same where everywhere in this thing. At least on this back terminal, they did push the wires through the hole, but still, if this ever overheats and it gets hot enough to where the solder melts, which can happen, especially if there's a failure somewhere in this thing, the fuse is meant to protect everything. The solder could get hot enough it could melt, then the wires can fall out. If you push them through the hole and fold them over, then that tension that's on the wire, it still doesn't have enough to pull it out because you at least have bent the wire over, so not done right. You can look at that relay down there, which, oh my God, we've got to get into how the relay and the power switch in this thing, that's just, wow. But how did they attach the wires to the terminals? Literally laid the wire on the spade terminal and attached it with a blob of solder. That is not how that relay was meant to be used. It was meant to either be used in a relay socket, or it should have proper push-on terminals. Spade connector push-on terminals is what should be on the end of the wire. They should have terminals on the wire and then pushed on to those terminals. Or they should have a relay socket and then have soldered the wires to the terminals on the relay socket. Again, it would have holes in it where you could push the wire through and fold them over. That's just, again, fire hazard and electrocution hazard waiting to happen. Anything overheats, the little bit of solder that's in between that terminal and that piece of wire there melts, the wire just falls off. Next, black wire. That's the hot wire. Okay, so if you follow that back to the terminal and the plug to your outlet, that's the one that has electricity on it. Okay, if you stick your finger in that hole, your outlet, you're going to get electrocuted. The other one is the neutral, and then you have your ground. So this is the hot. Hot is designated by black, white is neutral, so they've got the correct wire going to the fuse holder. They have the black wire going to the fuse holder, but what's on the other side of it? A white and two blues. It should be black. The last thing you want to do is put a white wire there. White, what did I just say designates? Neutral. Anybody in the future that ever has to service this thing is going to see a white wire, is going to figure white wire, it's a neutral. They're not going to be thinking it's a hot wire. White wires should be neutrals. The two blue wires go down to the relay. The white wire goes up to the power switch. Okay, so you follow that, goes down right here. Okay, see that comes up to the front there, to the power switch. Did I tighten that nut? I actually had that switch out because you can move the terminals on that. It's just, they're flopping around on there. That's how cheap that switch is. It is, again, some Chinese cheapest product, you know, cheapest thing made that apparently could be found to use in this thing. Now it does have ratings on the side of it somewhere. Yeah, we got 15 amps at what the heck does that say? 250 volts and 20 amps at 125 volts. That's all the markings on there. There's no safety ratings, there's no UL listing, nothing like that. There's not even a manufacturer's name or marking or anything. Yeah. And I know why there's no manufacturer's name, because they don't want to associate their name with this piece of junk. Like I say, the terminals, they're just flopping around. Now, how is this wired, this entire box of death? This is where it gets really interesting, and it's funny and scary at the same time, and also makes no sense. White wire, remember, this isn't a neutral, this is a hot wire, comes to the toggle switch. This is then the power coming out of the toggle switch. We have two small wires here. You know what's on those? DC voltage. I shit you not. They have AC at 120 volts on one side and DC voltage on the other side. Again, you've got to be shitting me. Oh. Follow the orange wire back. Comes back. What the hell is that? The wire wasn't long enough. We'll just tack on a little bit extra. You don't just tack on wire when you're manufacturing stuff. You use a proper length wire. If the wire wasn't long enough, use a longer wire. You don't just tack a little bit extra on. And that's not the only spot. There's some wire, wasn't long enough. We'll just tack on another piece. Here's another one. This one's also AC, hot wire. Wasn't long enough, we'll just tack on a little piece. That's not how you do this, folks. Unsafe. That is some really thin wall heat shrink tubing. I seriously doubt that stuff's rated for 120 volts. Yeah, it's just no way. This is the interesting part. This wire, if you follow it, okay, let's get it rotated around here a little bit more. You follow that wire, that comes over to that terminal right there, okay? We have load, neutral, ground. There are 3 commons, which are the negative terminals, the negative DC terminals. There's 3 positive V's, so that's your DC positive, and then there's a voltage adjust. All of this we'll get to. For right now, let's start with the load. That has a wire attached to it that pigtails and goes down to the one underneath it. That has a wire that pigtails and goes down to the bottom power supply. That's it. That toggle switch, when you flip it, turns on these 3 supplies. This is the interesting and kind of scary, weird part. These 3 power supplies turn on, they start making DC voltage. That DC voltage is then sent back up to that toggle switch on these small wires, or not those wires, the ones down on the switch. The small wires. That wire then comes back and trips the relay. The relay supplies power to the other 7 power supplies. What? Oh my God! You can't make this stuff up. They just put the wires in here. There's no terminals on any of these. They just got wires crammed in. These should all have terminals on all of these wires. What's attached to that? What is that right there? What is that little logo? Earth ground. What is attached to the earth ground? Nothing. Absolutely nothing. There is no earth ground. What about the one under it? Nothing. What about this power supply? Nothing. What about this one? Nothing. None of these power supplies are grounded. Absolutely none of them. Again, are you shitting me? Death trap. Where next? We'll just stick with the AC for a while. So, yeah, these are powered by the AC from the toggle switch. The other 7 are powered by these producing DC. The toggle switch then turns on the relay from that DC voltage. But yeah, AC and DC on the same switch. Wow. Wiring again. They've got AC and DC wires, because remember, there's a 10th power supply hiding up here in the front, so they had to run wiring up to this thing. So that's fine, they had to find somewhere to get it up there. They ran it in between here. What is this? A sharp metal edge. What do sharp metal edges do to insulation on wires? They eventually cut through it, especially this is aluminum, and it's a power supply. It's going to be going through high heating cycles, getting hot and cold, hot and cold. So the copper wire is going to be expanding and contracting. The aluminum piece of sheet metal here is going to be expanding and contracting. And it's zip tied on there. So you have AC wires right at that sharp metal edge. Where's the edge welting on there to protect that so it can't cut through that? They didn't go out and get a roll. That's all you need right there. Edge welting. It's plastic. You just cut off a piece of that stuff, you push that over the edge, completely protects it. Then you don't have to worry about chafing through the wire and it shorting out against this chassis that, remember, has no earth reference where it's supposed to. Is that it with the AC? At least a hot lead. Yeah, like I say, the other ones go down to the relay, the 2 orange wires down here on the relay. You have the blue wires off the fuse holder come down, supply to the 2 sets of contacts. Then the orange wires come up, just like over here. Orange wire, one orange wire comes up here, pigtails down, pigtails down. The other orange wire off the other set of contacts comes over to this power supply at the top, pigtails down, pigtails down. The neutrals. Okay, we've got lots of power supplies, so we need lots of neutral connections. How did we do the neutrals? The neutral wire comes in right here and goes to the black blob of death. Okay, at the black blob of death, we have 4 wires coming out the other side. Again, some thin, flimsy heat shrink tubing. Actually, it kind of... maybe there's electric tape under there? I don't know, I'm not cutting it off. But yeah, in any case, and I'm going to assume, at least I hope they soldered that, but that's still not right. You don't just take a wire when you're doing stuff like this, running AC mains, just blob it together and then have 4 wires spitting out the other side. If you needed more than one neutral, they should have put a terminal block in this thing. The neutral wire would have gone to the terminal block. Then you'd have the proper jumper links that you use on terminal blocks to expand out to as many terminals as you need, and each one of those wires would have had an eyelet terminal on it and would have gone to its own terminal. Not right. The DC in this thing. Ay, ay, ay. These power supplies are not, I repeat again, they are not designed to be used other than standalone. These power supplies are designed to be used by themselves. They're not to be run in series or parallel with any other power supply. We just went over what connections are on the back here, okay? Do you see anything, any other terminals for hooking up sense lines? No, it doesn't have it. Proper power supplies that are designed to be used like this, where you're going to be hooking up 1 or 2 or more of them in parallel or in series, depending if you need higher voltage or higher current. They have connections that link between power supplies. The power supply modules then have load sharing circuitry. That way no single supply will be running full bore while another supply over here, let's say, might be just idling along at half or a quarter current. It evenly shares the load over all of the power supplies. Now, you can, in a half-assed fashion, make a load sharing circuit, but they didn't even do that. Look at how it's wired. Every positive terminal comes down, has a ferrite bead on it, because remember, switch mode power supplies, they can tend to be a little noisy. So, yeah, they did go to the effort of putting ferrite chokes on everything. But they all come down, they all go straight to that terminal there. The output, same thing with the negative. All the negatives come down, all go down to the negative terminal. But there is absolutely no isolation between any of these power supplies. They are literally all connected directly to each other at these 2 terminals. If you wanted to half-ass a load balancing system for this, all you need are some resistors and diodes. Get yourself probably some like 15 or 20 watt half ohm resistors, the big power resistors that have they're built into a little heat sink, and properly current rated diodes. That way the voltage can't backfeed from one power supply to the other, and then the resistors help to balance the output power between all of them. That's a half-assed way of doing it, but in a pinch it does work in a half-assed fashion way. The correct way to do it is you just get power supplies that are designed to be used in parallel with each other. Oh, you're going to love this one. This just takes the cake. Of all the things that I see wrong in it, there's a lot of hazardous shit in here. Probably the absolute worst one I saw. And this is literally one of those you have got to be shitting me moments. I just could not believe my eyes when I saw this. And where did my pointer go? My God, it's stuck in my shirt pocket. It's kind of hard to see because it's under these covers, but each one of these power supplies has a fuse, okay? They each have their own fuse to protect them if something goes wrong in here. You know what's going to happen if something goes wrong in these power supplies? Nothing. They're going to burst into flames. Why? If you look down in here, don't pay any attention to this brown wire yet. We'll get to that. That's the fuse right there. There's a metal end cap. The glass tube, and get this damn brown wire out of the way, you might be able to see it, with the fuse element in the middle of it, and there's the end cap. What did they do? They literally soldered a wire across the fuse. They jumpered the fuse. Not just this one. This one What's it got? It's got a wire soldered across the fuse. Come over to the next one. Wire soldered across the fuse. Oh my God. I just... That's dumbfoundingly... the stupidity, the ignorance. It's just not stupidity. That's the ignorance of doing something like that. Wow. The brown wire. Okay. This has that control on the front. Remember? The blue one right there, okay, the variable control. Well, since these power supplies aren't designed to be used with each other, there is no way to control the voltage from one source to all of them properly. So what did they do? Well, I'm not going to take the cover off of this thing, but from the looks of it, you can see this brown wire here. I thought initially it went to that fuse possibly, and that didn't make any sense. I got to looking a little bit closer, and actually if you look down in there, the brown wire, actually, they just sneak them in over here. It comes across behind this bank of capacitors in there, and that's it right there coming out. Okay. And it's soldered, big blob of solder, looks like it goes to a jumper wire right there by the voltage adjustment. So it looks like probably what they did is they basically disconnected all of the voltage adjustments in these modules and have all of them, because every single one of these things has a brown wire attached in the same location. Okay? There's a blob of solder going down in there to all of these, and then those all go down to, I don't know what to call that. Your 2-year-old child's attempt at making circuit boards? That looks like that was made with a Dremel tool, quite honestly. That does not look like Dremel tool cuts. Really? You've got to be kidding me. A commercially sold product. It would be one thing, again, I might understand if Joe Snuffy was making it for himself. This is a product somebody sells commercially. Dude, circuit boards are cheap nowadays. You can get circuit boards made in China, and they're good quality from like Elecro. There's a lot, Christ, you can't throw a stone in Shenzhen, China anymore without hitting a PCB manufacturer. They're everywhere. Just go online and search. You could probably get this circuit board made commercially. A proper nice FR4, through-plated holes, gold-plated, silk screening of your choice of color for probably, what, $1.25, maybe $1.50, you know. Cheap, good high-quality board. Nah, we'll just with a Dremel tool, whatever. But anyhow, they have all of these wires for the voltage adjustment are all controlled by the same control up front. That's not going to work. If you turn that control up there, there's slight variations in every component. Doesn't matter, even precision components. You measure down to enough resolution, there's going to be a difference in resistance, capacitance, and inductance. No two things are exactly alike. So that means no one of these power supplies are going to put out the same amount of power if you apply that same power to all of them at their voltage adjustment point. They're all going to be outputting a slightly different voltage. And again, there's no sense circuit here to share load and voltage information, so yeah, that's completely wrong. Capacitors in this thing. There's just kind of haphazardly, kind of looks like stuck in this thing. We've got a aluminum electrolytic here. They both go down to this board down here, so that looks like that's the voltage supply in the ground that goes down to this board, slightly out of view there. Okay, they're picking up the voltage source for the voltage control right here. Got a big filter cap there. And actually, what is that? Oh, that's man, you couldn't have picked a better brand. Suntan. Yeah, that's what you're going to get if you leave the cover off of this thing and plug it into a wall. You'll probably get a suntan when it bursts into flames or it starts arcing. No name cap. A lot of people use them, but yeah, just buy good caps. But the application of ceramics in here seems a little haphazard. It looks like they've got, most of these have, it looks like, no, that one doesn't. Oh, nope, it does. It's hiding under there. So they have ceramic caps, and that goes across the negative and the positive for the DC output. They're just going to be doing some high frequency filtering, because remember, switch mode power supplies, these things operate at really high frequencies. Of course, we're going to be attaching this, well, I'm not, but it's designed to be attached to an amplifier operating on DC, so you don't want that high frequency content leaching into your DC, so understand. But then you look at, they've got two blue caps, okay? Remember, these are the AC terminals. So they've got, oh my God, is that, I can't believe that. Now I didn't notice that before. Wow. Wow, wow, wow. I didn't notice that jumper wire. We'll get to that in a second. So the two blue caps go from across the line here. They're using those as safety caps. They're not safety caps. They may be blue, but they do not have an X or Y rating stamped on there. It's just a capacitance value and the voltage rating. That's it. Yeah, those are not X or Y or XY rated safety caps. If I was going to put caps on there, they would be X1, Y2 safety rated caps, actually. But I just noticed that, well, that's why I say, man, there's so much wrong in this thing. What is that piece of wire? Remember, what's the third terminal? That's the common ground. They've got, which correctly, you would have your bypass safety caps going to the earth ground, but there is no earth ground. None of these things have anything on the grounding terminal. So they've got that run to the grounding terminal, but then what's the ground terminal attached to? It's attached to the DC ground. Oh my God. Talk about ground loops. Matter of fact, they did the same thing over here. Here's a bodge wire right there. There's the caps. There's the blue caps right there. They go to the lead, goes to the earth terminal, and then the earth terminal comes over and hooks to the DC ground. Wow. Just man. The output terminals on this. Will these work? Yeah, they'll probably be fine. But really, do you need bolts? You couldn't get proper terminals, a proper terminal strip to stick back here with the proper insulation and everything. Again, actually, speaking of ground, what do they have the negative attached to? There's no insulation here. Look, plastic, they're insulating the positive from the chassis. There is no connection, or there's no isolation of the DC from the metal chassis here. More grounding and loop problems you could have here. It just let's turn her around here so we can see these wonderful power supplies. Actually, and here's another thing, the wiring. Again, you take the cover off, you go to put the cover back on. The way these wires are routed, you can't get your hand up under the cover when you're sliding it down to hold these wires in, so you're always going to have a chance of these wires getting in between the metal cover when they come down over the side, because remember, there's the screw holes, and these wires getting pinched in there. Yeah, you could have routed these better and had them properly tied up. For God's sakes, at least put a dot of glue there or something. I just, wow. So what brand are these switch mode power supplies? There aren't. They don't have a brand. I actually looked. There's no name on these things. If you look up for a data sheet for an S24012, what this is a clone or a cheap knockoff of a Meanwell power supply. An S24012 is a Meanwell power supply. This is not a Meanwell power supply. This is a very cheap knockoff or imitation of a Meanwell power supply. Matter of fact, give me 4 or 5 seconds, I'll go walk out and I'll go get a Meanwell power supply. So you can see just the construction difference, how much heavier they're made. Okay. Now this one's much smaller. This is what? This is a 4.2 amp. You use these in base station. Perfect for a little base station CB radio power supply. Okay. Metal cover on this thing is really, really heavy. These are very flimsy. And look at that. See how you just grab that, it just pops out. No matter how hard I try and pull on these, you just can't pull the covers off of these things. They're just, and they're hefty. They're really well built. For starters, it says it's a Meanwell. These have no name. S240 AC input 110 220 volt, plus minus 15%. DC output 12 volts at 20 amps, made in China. 20 amps. That ain't right. We'll get into that with a datasheet actually in a minute. So it's a knockoff clone of a Meanwell. That's what they're just trying to pass that number off as. Yeah, this is a real Meanwell power supply. It even has the engraved, they're the professionally die stamped in the back of the metal plate to prevent companies from counterfeiting, because Meanwells are well made and they are made in China. And here's a good example of cheap Chinese crap and good high-quality Chinese products. Meanwell power supplies are used in everything nowadays. Good Lord, you even see these in test instruments nowadays. Industrial applications, consumer products, everybody uses Meanwells. They're just everywhere because they're good power supplies. This is not a Meanwell. We have no idea because there is no name anywhere on that thing. The rating. This is where it gets good when it comes to that 200 on the front. Like I said, I have to assume it says 200, and these say 20 amp, and there's 10 of them, so you would think 200 amp power supply. Nah, an S240-12 power supply, which is what they're cloning here, is a Meanwell power supply. Okay, S240-12. This is the data sheet for an actual Meanwell power supply. Okay, 12 volts, 18 amps. And the one thing you always have to remember with power supplies like this, especially when you're talking variable voltages, the current rating doesn't so much matter. That's the maximum current that it can make. The maximum wattage is what you're concerned about. It's only 216 watts, okay? If you crank this voltage up, as voltage goes up, your current rating goes down. As voltage decreases, the supplies can produce more current, okay? They're proportional. As one goes up, the other goes down, and vice versa. So these, having this voltage adjustment, because we all know that people that run the amplifiers, this thing's designed to be used with, run the voltages really high. So if this thing's going to be set at 14 or 16 or 18 volts or something, the current rating is going to decrease. Now, if we just go by the Meanwell data sheet, okay, like I say, 216 watts. Now, the Meanwells rate the S240-12 at 10 to 14 volts adjustable. Lord knows what they might have done to this voltage adjustment circuit. Like I say, I'm not powering this thing up, because honestly, don't most of those amp guys run those amps at like 18 volts or something? So Lord knows what this thing has been hot rodded to be able to put out. But remember, as the voltage goes up, the current rating drops proportionally. The other thing is, remember I said the power cord, okay? Input. There's your input voltage, where do we want? Right there. AC current. Typical draw. So that would be under maximum load. The typical AC current draw is 5 amps per supply. The maximum inrush current is 15 amps AC per supply. Even if we don't now, I'm going to assume probably the amplifiers, you're not going to be holding the microphone. You have the power switch on an amplifier, have your radio turned on, and have the radio keyed when you turn this thing on. So inrush current's just going to be enough to basically to energize all 10 of these power supplies and charge up all the capacitors inside of all of them. But it is going to be a large inrush current. The main thing is the maximum typical operating current, 5 amps. So when these things are running at their maximum rating, they're going to be drawing 5 amps of current. What was this power cord rated for? 15 amps. Let's do a little simple math. So I just copied down the specs off of that data sheet. 12 volt power supplies, they're rated for 18 amps at 216 watts. The listed adjustment range is 10 to 14. Like I say, we don't know what exactly has been done in there. I'm sure it's been tinkered with to get these things up probably to 18 or more volts. The AC inrush current's 5 amps at 115 volts, and the inrush current typical is 15 amps at 115 volts. So current, 5 amps times 10, if you're loading down this power supply at maximum, the most it can supply, at 5 amps per supply times 10, that's 50 amps. You have a 30 amp fuse, and worse yet, a 15 amp power cord. This thing is more than 2 times underrated for the amount of current, AC current, these supplies will draw. Huge fire hazard. And remember, 30 amp fuse protecting a 15 amp power cord. So if this thing's drawing a lot of power, this cord's going to get smoking hot. For starters, they do not make a 120 volt plug that is rated for 50 amps. There is no such thing. If you need 50 amps, you'd need to switch these into 220 volt you'd need to operate these, or you can't do it. There is no 50 amp 120 plug in the US. I don't know about other countries, but here we don't have that. I think we get up to 30 is the highest for 120. Next, how much power can these actually produce? Remember, it's rated at 200 amps. If it's set, let's just go with the data sheet. So we're going with best case scenario. If it can only be turned up to 14 volts, where was that? Yeah, 10 to 14 volts. If that's all the higher it can be turned up to, 14 volts, maximum current available per supply would be, our power, remember, they can only supply 216 watts. We use 14 volts as the maximum voltage. Current equals power divided by voltage. So 216 divided by 14 equals 15.42 amps per supply. 15.42 amps times 10 supplies, this entire thing would only be able to supply. Best case scenario, not accounting for any losses or especially any of the hocus pocus going on in this thing, maximum would be 154.2 amps. Yeah, it's not a 200 amp power supply. Like I say, this thing would catch on fire long before it got, it probably, even at 100 amps, it's still going to be drawn. Even if this thing is only putting out 100 amps, this power cord still is not designed to support that much. It would be drawing, remember, 50 amps at 200 amps. When this is putting out 200 amps DC, if it could, which it can't, it's 154.2 maximum if it was at 14 volts. And here's the other thing. Remember, if the voltage adjustment circuit's been modified so these can put out more than 14 volts, if it can put out 18 volts, that current rating is going to drop because the more the voltage goes up, the current goes down. Remember, it's directly proportional. P over E. It's simple Ohm's law. Just, wow. It just, and these power supplies, again, these are flapping in the breeze. They're connected with these little strips of copper, single side plated circuit board material. It's just, man. What? Where do you start? Where do you end? It's just, and there's more little nitpicky things you could go over. I'm just covering the big ones. Ideally, also on the output, for the positive and negative of this thing, it should have some type of filtering. Because again, we've got 10 switch mode power supplies. Switch mode power supplies are noisy. So you should have some type of filtering, ideally on the back of this thing. You should have an inductor and some capacitance back there to try and prevent that high frequency content from getting out to your amplifier, or your radio, or your arc welder. That's what this might be good for, arc welding. Yeah, until it bursts into flames. That's probably what this would be good for. Turn it on while you're wearing a pair of insulated rubber gloves so you never have to physically touch it, and then you could arc weld with it until either it catches on fire or the power cord catches on fire. Because Lord knows the fuse isn't going to blow first. It just... God. Like I say, it wouldn't be so bad if somebody just made this for themselves. That's perfectly fine. If you make a device yourself and it kills yourself, you know, hey, that's a shame. It's, you know, I don't want to see anybody die. I don't want to see anybody get hurt. But, you know, to commercially sell something, it's just, wow, the liability in this thing. Because if this thing does catch on fire and burn down a house that's got, you know, kids in it, you kill a whole family, or it electrocutes somebody and kills them, who do you think's going to be liable? Exactly. The company that made it. This obviously has no safety certification. Can you imagine the laughter? It would be heard around the world. It would be in the history books as the loudest laugh in history if you sent something like this in to a certification laboratory. They would remove the top cover on this thing, and that would be it. The engineers wouldn't be good for the next several weeks. They'd wake up in the morning laughing, and when they went to sleep, they'd still be laughing for weeks on end. I just, wow. So many things wrong. Just be aware, people. If you've got stuff like this, man, I'd recommend not using it, honestly, or open it up and see if it looks something like this. I don't know how old this is. Maybe they've changed their ways, how they make these now. I don't know. My first one I've ever seen, and hopefully the last one I'll ever see. Because, like I say, Mike ain't working on this thing. There's no way I'm attaching my name to this thing other than this video to show what it is. I'm not fixing it. I'm not even reconnecting that. I hate to say it. As much as I like the customer that owns this, I have done a lot of radios for that guy. He takes meticulous care of his radios, and he likes nice radios. There's no way I can associate myself with this thing, because then I would be liable. Like I say, the only thing I'm going to do is put a tag or a sticker on this that says it's not safe to be used. This is scrap metal. That's what it is. Either that or a nice empty box. Like I say, you could start from scratch. And ideally, that's what you do. Okay, if you want to turn this into if you wanted to make a proper 200 amp or somewhere thereabouts, 200 amp power supply, and you wanted to use switch mode power supplies, that's what you do. You go get like 450 amp power supplies that are designed to be connected to each other, that have a load sharing circuitry built into them. Better yet, just go get some old server power supplies. Those things, good Lord, you can get some of those server power supplies. Those things will put out like 60, 70 amps. I've got some of those things around here. Those things, honestly, make Meanwell power supplies look like Tonka toys. They make that look like an amoeba. But yes, server power supplies, those things are designed to be turned on one day and left on for years on end. When they get replaced, it's due to time. That's when they change out server power supplies. They just have a lifespan. That this year you replace all of them. They just replace them. They don't let them fail, in other words. But they're built like a tank, very, very reliable. But they can supply gobs of power reliably, 24 hours a day under load. That's what they're designed to do. Yeah, these things are probably, and I'm not going to take one of these out and pull the cover off. It's got perforated covers. Yeah, you can just look down through. You can see, I don't know how well the camera can look down through there. You see those resistors? I can just see those. I work on electronics. I've seen a lot of parts in my time. I can see the resistors. That's that blue color. I don't know how well it shows up in camera. I'm very familiar with that tint of color. It's not the standard blue that you would see on a flame-proof resistor that you get in this country. That has that cheap Chinese look. I've seen those things before. They're cheap parts. The Meanwell power supply, if you look down in here, now the blue things, those are proper safety caps. But you can see if you look down in here, these have the flame-proof, the gray resistors, okay, when you look down in there. And you can see they printed on them. Those are good, really high-quality resistors they use in this thing. This, cheapest thing they could get on the Shenzhen, probably every component in these boxes is the cheapest thing that was available on the Shenzhen market the day they assembled these. So, yeah. Like I say, if you've got a supply like, and I don't know, do the other amp builders make these things? If they do, I hope it's not like this. I think I saw a BBI one time. Somebody showed me a picture of one made by is it DBI or BBI? Hell, I don't even know. It's one of the amp builders. I think it's BBI, I think. That one actually looked halfway decent. Now, I'm not sure about the wiring. I only saw a picture. But that one was not a switch mode power supply. That one was a tank. It was a linear power supply made with big iron, big transformers. Okay, no switch mode crap. That one would just, yeah, it's kind of like that supply rate. Now that's a laboratory supply, but that supply rate, there's a linear Astron. The supply rate there, that's a linear supply. That's a 50 amp Astron. And matter of fact, that Astron has a blue terminal on the back of it. If I wanted to have a 100 amp power supply, that's what that blue terminal's for. You connect a wire to that blue terminal to the blue terminal on the other power supply. Guess what that is? It's the load sharing circuit that we were just talking about. So you can run those in series or in parallel to either double your voltage or double your current rating, and that blue wire then lets the power supplies share the load. So I'll end it here. It's just, wow. This is the beginning of the year. I don't know when the video will get uploaded, but yeah, beginning of the year, I can tell you right now, this is going to be the crowning jewel of the fail pile for this year. It's physically impossible to make something worse and less safe. Short of just attaching the hot wire directly to the cabinet, you couldn't make it any worse. I think that's the only way you could make it worse, is if you just took the hot wire and just attached it, just said, to hell with it, I'm going to intentionally kill somebody. We'll just attach the hot wire to the chassis now and get it over with. I mean, man. Scary. It's scary. That's what it is. Really, really scary. It's just, how many of these are out there? If any of you watching this video have one of these type supplies, I would highly recommend you unplug it at the very least. I'm not telling you to junk it. Unplug it, take the cover off, and look and see if it has any of the faults that I indicated in this. Improperly wired, improperly attached wiring, loose connections, loose fuse holders, wires that are improperly routed around sharp edges where they could get chafed through. Look for that. If you see stuff like that, then you shouldn't be using it. You're literally putting, if not just your equipment at risk. We honestly could care less about your equipment. What we care about is your life. We don't want you to die. We don't want you to lose your house. We don't want you to lose your family in a fire. We don't want to hear that somebody got electrocuted. Something went wrong in here, and your 2-year-old child just happens to walk by and touch the cabinet and gets electrocuted. That's the last thing we want to hear. So yeah, if you've got something, I don't care who made it. If it's not a true commercial, something that has safety ratings on the back of it, okay, that's actually been sent into a certification laboratory and it's been certified as safe to use, meets UL listings and all of the other safety ratings that are out there. If you don't see something like that on the back, at the very least, take the cover off of it and see if it has any of the scary shit like I just showed in this one. If it does, I'm going to recommend you not use it. You're putting your life, your family's life at risk, much less your property as well. So there you go. There's what was initially supposed to be a repair video, and yeah, turned into a scary bitching rants. I don't know what else to say. I mean, so yeah, it's going to get boxed up and sent back as is, unfortunately. So there you go, an X-Force 200 power supply that should be renamed the Fireball 200.